So these folks at Berkeley wrote some papers and did some calculations on how to price random wind. How do you price random wind power in order to get things to work out okay? Is selling random wind with variable pricing a reasonable solution to this? So they have a lot of results on that. They developed an algorithm to maximize welfare among all the wind producers. And so what you do is you sell the wind with a certain probability of actually receiving the wind. You sell contracts. And so they developed mathematical algorithms for how do you sell a contract that's varying over time for wind. And this permits interruptible power in the distribution system, but keeps reliable power at the bulk power system. So you have reliable power at the transmission level, but if you're going to sell wind randomly with random prices through an algorithm like this, which is very complicated mathematical analysis, then you have to have the users be willing to take interruptions in their power supply. There are a lot of systems and control and research problems related to distributed generation. And how am I doing on time? All right. That means I can keep you here for another hour. So a lot of research problems. I want everyone here to pick a research problem and try to work on it. System expansion planning, optimization for generation dispatch, all these things change because you have distributed generation. System monitoring, stability analysis, like I mentioned before. How do you cite renewables in order to have better stability properties, better reliability, control methods, which is my area for integration of renewables, cybersecurity for the grid, incentives for consumer behavior. This brings the social sciences into play. How do I incentivize consumers to give and take with the utility and accept what the utility is asking for in order to have a more reliable grid for everybody, and the interplay of policy and engineering. So there's we need new fundamental contributions in all of these areas. All right, so there's a lot of other things, for instance, simple stability criteria. You know, in power systems called the equal area criterion, and the pi over 2 polytope. Angles between the generators have to be less than 90 degrees for stability. All that goes out the window. And then you have a communication network and streaming data. You want to do a co-design, co-simulation of the physical network and the communication network. That's another major research direction. You have to deal with time delay effects in terms of information taking time to reach from one place to another. And then there are new issues of signal processing and data mining. Many methods that are used now are ad hoc, and they're wrong, and they've been used for the last 30 years in the power system area. You know, power system engineers tend not to be highly mathematical, but they tend to believe what they're saying. And I'll give you an example later where really we need to work more deeply on a lot of issues. How do you find the best place to put a controller and a sensor in a network? It's not a very clear thing. And there's a lot of, I have a few specific issues, and I don't want to spend all the time on these things. So, wide area monitoring and control. What is a mode of a power network? People talk about inter-area modes, local modes, all that stuff. They believe they understand what they're talking about. I say they don't know what they're talking about. They have an idea, but there's no mathematical statement. My research tends to be on the mathematical side in a few different areas, and so I care that you get things stated very clearly and have some clear results. Optimal placement of sensors and actuators, like I mentioned before. But you know, there's a trade-off between what you're trying to achieve. If you're trying to achieve stability, that's one thing, but you also need to achieve a reliable system and economically viable system. Also, there's the topic of battery health monitoring from external measurements using detailed chemical models. How do you make sure that the battery stack is healthy? Like I mentioned, all the modes of a power system. Big data experiments with consumers to understand strategies for incentivizing consumers. Wind power prediction to minimize the need for power reserves. If you could predict the wind energy into the future, like into the next half hour or so, then you can do a better job with power reserves. Here's some information now about NSF and our research funding picture. NSF has an $8 billion per year budget. Engineering is actually a smaller part of NSF, which is about $800 million per year budget. And this is the budget of NSF over the years from 2006 to the 2015 request. You'll see that there's a jump in 2009. That jump is the beige area in that picture in 2009. This is because of the financial collapse in 2008, and the government gave a stimulus package, the ARA package. And we have, in the engineering program, we have several divisions. I'm in this division here. There's also at the bottom, there's an industrial innovation and partnerships program, which supports companies. We have a research centers program. There are a few research centers related to power. And if you look at the websites of these research centers, you might find some things that you find interesting. The Freedom Center is at North Carolina State University, which deals with development of a new generation of distribution systems. And I think in Palestine we don't have much in the way of a transmission company, but we do have distribution companies. And I think they would be very interested to see the new technologies, solid state transformers and so on that are being developed at this center in North Carolina State. These centers tend to have a few universities working together and companies working with them. The current center deals with wide area modeling and monitoring and control, wide area power systems. They want to model the whole North American grid. And we have cooperative industry university research centers. There's a list of them all related to the power area funded by NSF. Our program in particular, the EPCN program, Energy, Power, Control, and Networks, you can see the list of areas that we fund, from control theory to power, energy, wind, batteries, solid state, policy economics, even quantum mechanical stuff related to energy is in there. Control and optimization of buildings, transportation, and robotics. So we have a big portfolio. These are the program directors right now. I'm what they call a rotator. The other two are permanent people. Rotators come from universities for a few years and go back. These are a few of the different areas we've been involved in, helping DOE with their initiative of Stephen Chu related to solar energy. Now, I mentioned that I wanted to talk a little bit about opportunities for researchers in Palestine to cooperate with researchers in the United States. The main opportunity is from USAID. There's a website here that I'll share with anyone who needs it, and you can collaborate with a U.S. investigator who's funded in the United States, and USAID can provide financial support here. So that's the only true program that provides direct funding for overseas organizations from the U.S. But you need to find somebody in the U.S. who's funded in the U.S. by some agency. It doesn't have to be from USAID. It could be from NSF, from Air Force, from any place. And the deadline is always in January. So if you want to plan for next January to get on board and apply for a grant from USAID in this area, you should start planning now and find a colleague in the U.S. that you'd like to work with. Also, there's the NSF International Programs Division, which can be utilized to help getting involved in a U.S. grant. I have a mathematical research topic that I thought I'll mention to you, research results that I obtained with colleagues from Palestine, just because I'm proud to have done this work with people from Palestine. I've had several visitors from Palestine in the United States in the past, and this is joint work with Waran Hashtaroun from Birzeit University, former Dean of Engineering there, and Mundar Hassouna, who was my student that came from Birzeit and finished his PhD at Maryland, and now he works for NASA Goddard, and he's putting stuff on space in the International Space Station. So this is on modal participation analysis. I'm not going to go through all this in detail. But the fact is that there's an area called modal participation, which started in 1980 at MIT. And I started looking at that over again, which modes, are eigenvalues in the system. And we talk about the slow modes of a power system, inter-area modes, and so on, like I mentioned before. And we revisited this concept that has been in the field for many years and found that we can make major changes to this area. For students who study differential equations in class, the older guys forgot all this already. X dot equals AX. A is a matrix. It has some eigenvalues. And if you model a power system in this way, then those eigenvalues are the modes of the system, e to the lambda it. And if you look at the evolution of the state vector, x of t, you can decompose it in this way in terms of the eigenvalue, evolution e to the lambda it, and Ri are the eigenvectors. X0 is the initial condition, Li are the left eigenvectors, Ri are the right eigenvectors. And the kind of questions that people ask are, how much does a mode participate in the state? How much does the state participate in the mode? And this started in 1980-81 with introduction of these quantities, the PKI, that they call the participation factors. PKI is the left eigenvector Li, its kth component, times the kth component of the right eigenvector. They called that the participation of the ith mode in the kth state. And they had an analysis of it, of how they got there, which is based on choosing a particular initial condition. And that's been used. You can look in all the power books, you'll find this participation factor. They're dimensionless. And they also studied the participation of the ith mode in the kth state, and they ended up with the same formula by using a different initial condition. And with my friends from Palestine, we revisited this and said, well, the initial condition, you can't really say what it is. You can imagine that it's a random initial condition, and let's see what happens if you take it to be random and you average or take the mathematical expectation over time. And we ended up with a definition like this, where we take the average over the initial condition, the contribution of a mode to a state, and you can go through the calculations. You find the old formula under some basic assumptions. But if you look at mode and state instead of state and mode, you end up with something really complicated. And you have to go through a lot of analysis. And you end up with these formulas. You know, participation factors, that formula up there, for example, end up being much more complicated when you're looking at the participation of a mode in a state. And people don't understand, what does it mean to say that a state affects a mode or a mode affects a state? Does it mean that a machine has more impact on an inter area mode than another machine? What does it mean? So something that was sitting around for the last 35 years and everybody believed it really needed to be looked at again, and it still needs more work. So here's a summary of my presentation. There are a lot of fundamental issues still needing study in power networks, and those issues are growing with the growth of distributed generation. There are opportunities for collaboration between the U.S. and Palestine and other countries through AID and NSF. I'll be very happy to help people make contact. They're serious about doing research jointly with researchers in the States. And this is a very exciting field for research and innovation with a lot of interesting open problems. And I hope that people here will contribute to this field. I see that there's already a lot of contributions going on from the conference proceedings. I'm very, very impressed by all the work that's happening here. I'm very, very proud that the people from my homeland are doing all this work. I'm really proud of them. And that's it. Thank you.
شكرا دكتور اياد. يعني انت في النهايه في السمر بينت انه شو ممكن احنا نستفيد من الخبرات والامور اللي اطلعنا عليها، وبحكم اني انا مدرس في الجامعات يعني كل المواضيع اللي تحدثت فيها هي مواضيع ساخنه على المحك. فانا يعني سعيد جدا اول شيء انه ممثلين عن جامعاتنا ولا سيما اخواننا من الجامعه الامريكيه العربيه الامريكيه في جنين يعني مشاركين معنا، لكن سهوا ما مرحبناش فيهم، اهلا وسهلا. نستفيد يعني نحب نستفيد من زملائنا من الجامعات انه عمليه التشبيك في عمليه الريسيرش، ولا سيما كمان شركائنا شركات توليد وتوزيع الكهرباء. برضه الامور اللي تحدثت فيها برضه في زيارات لهم يعني اطلعونا على هذه المشاكل اللي في اثناء يعني عمليه الجنريشن وعدم تطابقها مع الديماند. فشكرا على تغطيه الموضوع. احنا بدنا ناخذ 5 اسئله او مداخلات صغيره. فدكتور معتصم دقيقه. دكتور معتصم مين كمان؟ طب تفضل على هون عشان نعرف عليك. بدي اخذ هي اوكي.
الصف الاول له اولويه.
لا ما هو احنا بلاش فوق من الاخوان فوق في حدا. دكتور زوردي كنت تساله شيء؟ عشان قاعد بحكي دكتور بس مين كمان؟ قدام الشيخ تفضل. شو الاسم؟ تفضلوا أرجو اللي بدهم يسألوا هي الميكروفون، وبعد ما يخلصوا الأسئلة أو المداخلات بنعطي المجال للدكتور إياد يجاوب. تفضل يا دكتور.
اولا انا بشكر الدكتور اياد على قبول دعوتنا للمشاركه في المؤتمر وحضوره، اهلا وسهلا فيه، واشكرك جدا على المحاضره القيمه اللي اتمنى انه اخواننا وزملائنا في شركات توزيع الكهرباء اللي اصبح الان عندهم اهتمام كبير بتوليد الطاقه المتجدده، استخدام الطاقه الشمسيه بالذات، والمحاضره يمكن اعطتنا فكره اوضح عن المشاكل اللي ممكن نواجهها في المستقبل. السؤال انا بدي اساله شوي هو نون تكنيكال. انا عشت او درست في الولايات المتحده في بدايه الثمانينات او وسط الثمانينات، وكان توجهي الى دراسه الرينيوبل انرجي، ولكن واجهتنا مشكله انه في هذه الفتره انخفض اسعار البترول انخفاض حاد، كانت دون ال $20، وفجاه كل مؤسسات الدعم مؤسسات البحث العلمي انه في الولايات المتحده اصبحت غير راغبه في تطوير الرينيوبل انرجي لان اسعار البترول اصبحت في الحضيض. الان احنا مع بدايه 2015 بدانا نواجه نفس المشكله، انه الان فجاه قد تكون الاسباب سياسيه، قد تكون اسباب اخرى، انه انخفضت اسعار البترول والغاز انخفاض حاد. يعني برميل البترول اللي كان في العام الماضي حوالي 115 $116 الان دون او حوالي $45. هل تعتقد انه هذه ستؤثر سلبا خلال السنوات القادمه اذا استمرت لفتره طويله، انه ستؤثر سلبا على التوجه للرينيوبل انرجي، للسولار، للويند، لانه رح يصير عندك المنافسه اللي بدينا نشعر فيها بالخمس او 10 سنوات الاخيره شجعتنا جدا نتوجه للرينيوبل انرجي. الان ناس كثير عندنا في فلسطين عمالهم بيشتروا فوتوفولتايكس بركبوها على بيوتهم، شركات الطاقه عمالها بتشتري بالميجا واتس. زي ما سمعت الدكتور عمر اليوم قال انه صارت عندنا الكباسيتي اكثر من 10 ميجا وات. طبعا 10 ميجا وات بالنسبه للولايات المتحده رقم تافه، لكن بالنسبه لنا هي نسبه عاليه. فبالتالي هذا قد التوجه العام ممكن انه يغير كل المعايير الاقتصاديه او الاهتمام فيها. ما هو شعورك وما رايك في هذا الموضوع؟ شكرا جزيلا.
حاتم عبد الله، مهندس ميكانيكي من هيوستن تكساس، بس اصلا من البلد من هون. الديستريبيوتد جنريشن التأثير السلبي او النيجاتيف امباكت on the distribution system of the distributed generation, is it still valid at local level, let's say net metering at the low voltages and amperages for smaller installation?
السلام عليكم، الدكتور أسامة العمري من الجامعة العربية الأمريكية. شكرا جزيلا على هذه المحاضرة القيمة. سؤالي بالحقيقة تقني. So I may speak in English. My question is, since we are considering this distributed generation, this means that we are integrating more and more renewable energy systems to produce electricity. And as the amount of power produced is growing, then we are facing a problem with controlling the grid, as I understood from the presentation and as we know. Therefore, maybe we need to think about this generation of power from the small renewable energy systems. Let me say small because most of the time they are this way. We are still looking to those systems as negative loads. This means that they are loads, but they are producing energy and not consuming them. And the fluctuations in the generation can be or averaged by the consumed loads, and then we have to deal with the system. But We are now maybe thinking about what we call active integration of renewable energy systems. And in the same way, we consider the electrical buses as slack bus, regulated bus, and load bus. We may think about considering those renewable energy systems or dividing them into the same system. This means we may think of some kind of active integration. Does it worthy going in this way more and more? I want just to hear your opinion. Thank you very much.
من وزارة التخطيط والإسكان. I'm a mechanical engineer, so my background is quite different. From my aspect, the storage seems to be a crucial issue with distributed grids, the stability of distributed generation. So my question is really, I'm wondering about the possibilities, what research has been done, particularly with the issue of storage. What kind of research has been done? Say, you mentioned that one option was to use residential water heaters as virtual storage. So my question, what about the possibility of using district heating systems in the shape of a geothermal well, for example, in the winter time? And when it comes to summertime, what are the possibilities of using the extra generated power into, let's say, seawater desalination, the extra power? So those were the questions that went through my head, and especially when it comes to storage, thermal storage.
شكرا أهلا وسهلا. تفضل.
المهندس عبد الخالق برضه في شركة تنظيم وعضو اتحاد شركات العامل الطاقة الشمسية. شكرا للدكتور على المحاضرة القيمة. أنا سؤالي عن الجريد الموجود عندنا في فلسطين، يعني كيف ممكن من الدكتور عنده معلومات لتطوير هذه الشبكة لإدخال موضوع اللي هو السولار بانل أو الويند توربين لموضوع الجريد بتاعتنا. فإحنا بدنا نستفيد من خبراتك كونك يعني في أمريكا، كيف ممكن نطور هذه الشبكة لإدخال قديش ممكن يعني من السيستم، لأنه بنعاني بصراحة اللي هو من موضوع الجريد. وشكرا.
أنا بدي أسأل سؤال للمهندس عبد الله العراق، إذا بحب يسوي مداخلة لأنه ممكن يجي هون برضه. أهلا وسهلا. تعال.
السلام عليكم. ما شاء الله صوتي عالي. عبد الله العراق دير كهرباء وباص. قبل المداخلة بس حابب أسأل سؤال. البرومر اللي هو الكاستمر والبروديوسر بالوقت نفسه. ذكرت انه عندنا مشكله وتحدي، انا بعتقد انها مش ابسط التحدي. متى بيكون يعني انف هاي وصلتوا لمرحله 15% 20% للبنتريشن للرينيوبل انرجي في فلسطين خصوصا، انه عندنا مشكله اهم من الاستيبيليتي بصراحه اللي هي تزود. يعني عندنا مزود واحد اللي هو الشركه الاسرائيليه، واحنا شخصيا كشركه طوباس طلبنا منهم من 5 سنوات ودفعنا الرسوم والخطوط مبنيه، للاسف الشديد ما قامت بتزويدنا. كفلسطين بهمنا في الاول وجود الباور سواء ستيبل ولا مش ستيبل، هي المرحله الثانيه بتقدم بعدين. السؤال بعيد بكرر، متى بيكون الحد الفاصل بين انه صارت مشكله وتحدي ومتى بتكون لسه لو سمحت؟ وضروره بالنسبه لي.
شكرا.
سأل سؤال بالنسبة لأسعار البترول. أنا عندي رأي بالنسبة لأسعار البترول وبالنسبة للسولار انرجي، وهي بتصور ما فيش علاقة. أنت فعلا كان في الزمان كان في علاقة، اليوم أعتقد ما فيش علاقة، عشان يعني تكلفة السولار انرجي نزلت كثير. وبالنسبة لسعر البترول توقعي إنه بينزل بس بيعاود يطلع بعد فترة، ممكن حوالي سنة زمان بيعاود يطلع. عشان انا بتصور اللي بصير حاليا مش شيء سياسي، هو اقتصادي. طلعت شركات الشيل اللي بيطلعوا البترول من الصخر وبتكلفهم حوالي من 40 ل 50 دولار البرميل عشان يطلعوه. في الامارات العربيه المتحده بتكلفهم 2 او 3 دولار البرميل، والسعوديه ممكن 4 5 دولار. فهم ممكن يتحملوا تخفيض سعر البترول على سنوات، وفي عندهم فايض من المال ممكن اجنبيه، وفي الاسواق المال ممكن يعني يمشوا حالهم سنين. فانا بتصور اللي عملوه يعني مشان ينزلوا هاي الشركات. في كثير منها في امريكا وكندا وقفت اعمالها، في منها سكرت، في منها اكثرها بطلت المشاريع، وقفت المشاريع اللي كانت في المخطط تبعهم الملياردات. فبتصور هاي الشركات في منها راح تنمسح من الوجود، وما تبقى منها بيكون ماشي حاله، فبرجع في اتزان في السوق وسعر البترول بيعاود يطلع. انا هذا توقعي. بعدين البترول هو يستخدم للمولدات الكبيره، باور جنريتنج ستيشنز الكبيره. ما له علاقه كثير في اشياء يعني محليه، يعني بيوت وشركات تحب انه يكون عندها مولدات صغيره. العلاقه في شويه بس مش قويه كثير، مش متينه كثير. لو نزل البترول ل 20 دولار مثلا يكون الوضع غير. بس حاليا مع دعم الحكومات للطاقه الشمسيه وكذا بتصور بضل الموضوع ماشي زي ما هو وفي تزايد مع الوقت. هذا تصوري طبعا. الاخ حاتم من هيوستن كان عنده سؤال. نيجاتيف there's a negative impact بالنسبه للlocal level. small installations on the mills الصغيره، هل في نيجاتيف امباكت؟ النيجاتيف امباكت هذا اللي حكيت انا عنه بالنسبه للشبكات الكبيره. لما يكون عندك مولدات كهرباء شمسيه او حسب بسموها ويند انرجي، ايش بسموها بالعربي؟ هوائيه، رياح. طبعا انا بفضل هوائي احسن. انا الهواء هوائي، طاقه الرياح. هذه يعني بصير لها تاثير على الشبكه الكبيره، على المستوى المحلي المحدود ما لها تاثير. والمشكله لما تاخذ هاي الطاقه وتدخلها في السيستم الكبير، النظام الكبير، بصير لها تاثير طبعا. عشان النظام هذا اللي هو بيوزع الكهرباء وبوصل الكهرباء من مكان لمكان على مستوى دول، ما انشئ ولا صمم على اساس انه يقدر يتحمل الطاقه اللي جايه من هاي المولدات الصغيره. دكتور أسامة العمري. Active integration of renewable energy systems. Is it worth going in this direction? الactive integration طبعا مهم، وفي ابحاث في امريكا